Alright guys, so today we're going to be talking about the product rule, and firstly let's talk about when would we use the product rule. So let's say we want to take the derivative of something of the form something like that. Well, at this point there's really no problem because you could FOIL this out and you would get x times x squared, x cubed, x times x, x squared, x times 1, x, plus 3 times x squared, minus, sorry about that, minus 3x plus 3. And then you take the derivative of that expression. And I can compute it right away. I don't need to, but we can collect like terms firstly. So here I do minus x squared plus 3x squared is going to be 2x squared. Then I get plus x minus 3x, so minus 2x plus 3. And now I can take my derivative by using the linearity of the derivative and my power rule. So in this case, and we did that a few times ago, so here we drop the 3, we copy the x, subtract 1 from the exponent. Here we drop the 2, so they give me 2 times 2, 4, subtract 1 from the exponent. And this one is just the derivative of 2x, which is going to be just 2 times the derivative of x, which is 1, 2, plus the derivative of 3, which is the derivative of a constant that is equal to 0. So we get the derivative to be 3x squared plus 4x minus 2. So you would think, well, then I didn't need anything else to compute it. I know how to compute it already. However, the product rule helps us when we would like to compute the derivative of something, d by dx, of the form x times sine of x. For example, I know how to take the derivative of x, and I know how to take the derivative of sine, but I don't know how to deal with that product. So do I just take the derivative of the first and the second and multiply them together? And the answer is no. The answer is we need a new rule to compute that. So let me write the rule over here, and then we'll compute this derivative by using that rule. All right, so let me write what the rule will be, and I'll leave this one here so we can apply the rule on this example again, so you compare to what we did before. So the derivative of the product of two functions is going to be the derivative, and I'm going to write it with the prime, of the first function times the second plus the first function times the derivative of the second. So in this example here, I would get the derivative of the first, which is going to be derivative of x plus 3, times the second, plus copy the first, times the derivative of the second. So let me take that derivative here. Derivative of x squared is going to be 2x, and the derivative of x is going to be minus 1, plus the derivative of 1, which is 0. I just computed it in line because I was running out of space, so I wanted to compute it here. So here the derivative of x is going to be 1, plus the derivative of 3, which is 0. And you get that derivative right there. Now it would be a matter of FOILing this out to compare with the answer we got before. And you see you're going to have 2x squared plus x squared to be 3x squared, which is what we had gotten. Where you're going to get 6x minus x, I believe we had a minus 5x. No, minus 4x because you have a minus 1. So minus 4x plus 1 minus 3, so minus 2. So we have to go back and check the video and make sure we got the same answer. And this is going to be a typical question in an exam where you're going to have the product of two polynomials, and it's going to say compute it in two different ways, using the product rule and by distributing and taking the derivative afterwards. So you can do it both ways in this situation, and you should get the same result. Now, let's take a look at this one right here, because this one is where you can no longer distribute. There's a trigonometric function, so you have to now deal with the product by using the product rule. So let's go ahead and look at what we get. Derivative of the first, by the way, this is going to be my f, and this is going to be my g. So let's call it just f and g, technically of x, but I don't have room to write it, but so f and g. Derivative of f is going to be the derivative of x, which is going to be 1 times just g of x. G of x is the sine. Plus, copy the first, which is going to be x, times the derivative of the sine. The derivative of the sine, we agreed last time, that was cosine of x. So that right there gives you your derivative, which is going to be just the sine of x plus x cosine x. So let's think about other examples that we can compute. So let's compute the derivative, for example, of e to the x sine of x. So almost the same, but just to practice. Derivative of the first is going to be e to the x. Copy the second. Plus copy the first. It doesn't even look like I did anything because I'm copying the same expression. Remember, the derivative of e to the x is e to the x. And then the derivative of sine, which is going to be cosine x. So here, this one is nice because you can factor an e to the x out. And you can write it like that, e to the x times sine of x plus cosine x. So let's take a look at this one here. This one is one of those that you could possibly distribute things out, and you could write it, you could do it in two different ways. So if you distribute it out, you would do your algebra first. So this would be x to 1/2, and you would have x squared. So this would be x to the 2 plus 1/2, which is going to be 5/2. And then 3 times x to 1/2, which is going to be x to 3/2. And when you do that, you would then drop your exponent. And then you get x to the 5/2 minus 1, x to the 3/2, minus, you drop the exponent here, you have 3 times 3/2 is going to be 9/2. That I'm going to comment here is 3 times 3/2. That's what I did there. X2, and you subtract 1 is going to be 1/2. All right, so this could be a perfectly good answer, or you could factor an x to 1/2 out of here, because it's a common factor in both terms. And you get, and even you could pull out a 2 out of it, and you get 5x that comes out of this one. You see, you're dividing the 2, putting it out here, and then you're grabbing 1/2 out of this one. So you have 3/2 minus 1/2 is 1, and then minus 9. So you could factor it like that, make it look a little bit nicer, or leave it like this if you feel more comfortable. Now, if you wanted to do it with the product rule, then what you could do is derivative of the first, the whole thing in parentheses, times the second, plus copy the first, times the derivative of the second. When you take the derivative of this, let's do it as an aside because some people struggle with this one. So let me take that derivative here. You would consider the derivative of square root of x as the derivative of x to 1/2, which is going to be 1/2. X to 1/2 minus 1 is going to be negative 1/2. So you can write this as 1/2 square root of x. This is one that I like computing separately because then whenever we see the square root of x, we just do 1/2 square root of x. So we don't have to be computing that one all the time. We kind of just remember it. I copy this one. And then here, this, I already have a, I didn't do that part. I'm going to have to put a 1/2 with it. But the x squared over square root of x is going to correspond to a 1/2 of x. And this right here is going to correspond to the -3 at the end. All right, so now it is just a matter of getting a 1/2 common factor out of here. So this one comes out with a 4x minus 6 plus, in this case, an x, and then minus 3. So we're going to have your 5x minus 9. Am I fitting that there? Yes. So as you can see, we could get the same result in both ways. This one was using the product rule. This one was just doing algebra and computing the derivative second. I mean, in my opinion, this one turned out to be easier. It's not always the case. Sometimes the product rule will make it, or most of the times the product rule will make it a lot simpler. So we have right there 4 different examples of the product rule.